What we completed yesterday. I color coded these so I can kind of show you and review with you where the similarities lie. So first step is hopefully we understand we're just basically adding, to find angles, we're just adding 30, 45, or 60 all the way around the circle until we get a 360. Okay. For the radians, we're either adding 1/6, 1/4, or 1/3 all the way around the circle until we reach 2 pi, right? Or until we reach 2. And then we just think of pi as just something that we have to include as part of our fraction. Anything with 3 in the denominator is going to all be similar to each other. So pi over 3, 2 pi over 3. These are all the angles that are furthest up, away from the x-axis. All the middle angles have pi over 4, and those are all, they all will share a similar order pair. And then finally, anything divided by 6, these are the ones that are going to be closest to the x-axis. These all have reference angles of 30 degrees or pi over, 30 degrees or pi over 6, and these are all similar. So we talked about yesterday how we can build order pairs. We haven't really talked about what those order pairs mean. Yes. Oh, sorry about that. Okay, we haven't talked about what these order pairs mean, but we talked about how to build them, right? And we build them by understanding that all the order pairs are going to have a denominator of 2. We start at the upper left corner, and we say 1, 2, 3, and then we work our way back up 1, 2, 3. Every numerator will have a square root, except the 1, because square root of 1 is just 1, so there's no need to put that square root of 1 there. Okay. Everything with anything with a 3 in the denominator will all have the same order pair all the way around. The only difference is the signs. Okay. Anything with pi over 4 in the denominator will have this order pair. Anything with 6 in the denominator will have this order pair. Okay. Once you copy all that, then you have to make sure your signs are correct. So anything in the second quadrant will have a negative x value and a positive y value. Make that adjustment. Anything in the third quadrant will have negative x value and a negative y value. Make that adjustment. Anything in the fourth quadrant will have positive x value and a negative y value, and we'll make that adjustment. Okay. So using this unit circle, we're going to practice building these trig values, okay, these trig values. And one thing I want you guys to copy down at the top of your page here is this. All these order pairs are x and y values, and the x and y values are going to correlate with cosine and sine. So basically, any x value that you see is cosine for that angle. Anything that you see on the y side is the sine value for that angle, sine ratio for that angle. Okay. So let's go to this unit circle table of values, and we're just going to practice finding all these values here. Okay. So for 30 degrees, there's pi over 6. So for radian, if you guys can put pi over 6. The coordinates, these are the coordinates that we have for pi over 6, root 3 over 2 and 1/2. Okay. And I want you guys to put this at the top. Okay. So the coordinates are obviously x and y values. So I'll put that x followed by y. Cosine is just the x value. Okay, so just put an x for cosine. Sine is simply the y value. Okay, put a y here. Tangent is sine over cosine. Okay, but something that's maybe easier to remember is the fact that it's simply just y over x. So either way is fine. You can think of it as sine over cosine or y over x. Okay. Secant is reciprocal of cosine. So you can think of it as 1 over x, or you can just think of it as, I'm going to flip the cosine fractional value. Flip cosine, basically it. Okay. Sometimes if you think 1 over x, maybe it's complicated because of complex fractions, but if you just want to think of it as, okay, I'm just going to take my cosine fraction and just change the numerator and denominator order. Cosecant is 1 over y, or you can think of it as flipping the sine fractional value. So basically, find the sine value and then flip it. If I want to find secant, I find cosine value and then I flip it. Okay, cotangent. You can think of cotangent as flipping tangent, or you can think of that cotangent as just cosine over sine, or even easier, just think of it as x over y. Okay, so everything involving pi over 6 or 30 degrees will rely just on these order pairs. Okay, so let me go through this one by one. Cosine of pi over 6, I could build a triangle and do all that, but I already have everything found from my unit circle. So cosine of pi over 6 is just going to be root 3 over 2. Sine of pi over 6 is going to be the y value, so it's just going to be 1/2. Tangent of pi over 6, it's just going to be y over x, or in other words, sine over cosine. Now, if I'm doing y over x, that looks a little messy, right, with the fractions, but the nice thing is that the denominator is just 2, so just cover up the 2, and we'll just divide the numerators. So what's y over x going to be? 1 over root 3, okay? So put that down first. We do have to rationalize the denominator. So 1 over root 3, if I rationalize the denominator, so times root 3 over root 3, I get root 3 over 3. Okay, any questions so far? Are we okay? Okay, secant. Secant means I'm going to take my cosine, which is my x, and I'm just going to flip the order. So because cosine of pi over 6 is root 3 over 2, secant of pi over 6 must be what? Okay, what happens if I flip this? Yeah, 2 over root 3, and I can go a little further if there's a radical in the denominator. So times root 3 over root 3, I get 2 root 3 over 3. All right, cosecant. Yeah, cosecant, I'm going to understand I'm dealing with the sine, look at my sine value, and then just flip my sine value fractionally. So 2 over 1 is just equal to 2. Okay. Cotangent of pi over 6 is just x over y. So there's my x, there's my y. I'm dividing fractions, but the denominators are the same. Those will go away. I'll just cover them up. So what's x over y? Yeah, root 3 over 1, which is just root 3. Okay, any questions with those? If you know the order pairs, you're just building everything off of the order pairs. Either you're putting one over the other, or you're just flipping the fraction, or you're just picking the x or just the y, just depending on which one you're after. What do you mean? That's right. Yeah, you don't have to put over 1. You can just put 2 or root 3. But if you put over 1, I mean, I'm not going to take points off either. But yeah, typically if there's a 1 in the denominator, we typically just drop it. And since it doesn't help, it's not we can simplify a little further. Okay, so we're good with 30, 45, 60. These all kind of follow the same pattern. There is a little bit of difference with the quadrant angles. So let's explore one of those. Let's do a 90-degree one. Okay, so 90 degree, that's pi over 2. And we look at the order pair here, pi over 2. My order pair is 0, 1, right? 0, 1. Okay, so let's go through this here. Cosine of pi over 2 is going to be what? 0. Okay, we just pick out whatever value you see. Sine of pi over 2? 1, okay. All right. Tangent of pi over 2. Okay, so you see 1 over 0, right? What happens when we divide by 0? We can't, so we call it undefined. UND for undefined. Okay. If you tried entering 1 over 0 in your calculator, you'll get an error. Okay, so we can't divide by 0. Okay. All right, secant. Secant means I'm going to take my cosine and flip it. So think of 0 as 0 over 1. So if I were to flip 0 over 1, it becomes 1 over 0. I can't do that, so this is also undefined. You guys don't have to write 1 over 0. You can just put UND for undefined. Okay. Cosecant of pi over 2 is 1, right? If I take 1 over 1, if I flip 1 over 1, I still get 1. Okay. Cotangent of pi over 2. Yeah. 0 over 1 is a real number. That's equal to 0. So I want to make sure that we understand how to deal with zeros. If you see 0 in the denominator, that's not a real number. We say undefined. But if you see 0 in the numerator and a non-zero in the denominator, that's a 0. Yes.
So why is 90 degrees 0, 1?
Okay, the reason why is because imagine this is a coordinate plane, and you're sitting here at 0, 0. All your radius is 1 unit away. So what's my order pair then up here? 0, 1, because I'm 0 horizontally, but I'm going 1 unit up. Yeah. So all your quadrant order pairs, they're all just going to be 1 unit away. Imagine taking a coordinate plane and just zooming in just around between -1 and 1. Good. Yeah. Any other questions? Okay. Okay, so this is basically my assignment for you guys today is I want us to practice filling in the unit circle. Ideally, if you can try it from scratch, just so that you can understand where you are with understanding. But the idea is if you can fill out your first quadrant, then everything else you're just either adding the same degrees over and over again to get to the next one, or you're adding the same fractions over and over again to get to the next one. And all your ordered pairs are all going to be built off of that little pattern that I showed you. Okay, and then you can list out all your radian measures, list out all your coordinates, and then use the coordinates to build all the trig values at those special angles. Okay. So want to give you guys the rest of the class to work on this. I'll walk around, see if you guys have any questions, but then towards the end, I will put the answers up so that you guys can check your answers. And if we have time, I'll maybe go around and just check you guys off for your homework. So there's nothing you need to do for tonight. Just do everything in class. Okay, so gonna have you guys work on that. And I'll see if you have any questions and how I can help you. And then by next Wednesday, when you do take your quiz, it's gonna be non-calculator. So you're just gonna have to be able to add those fractions and those values on your own. But after seeing it a couple times, hopefully it will just stay. Okay, if something in the unit circle doesn't make sense, or you don't see how some of the angles are found, definitely don't hesitate to ask. I want you to feel comfortable with every part of this process. You see zero, you're going to force zero to a fraction. It's really zero. So I flip 0 over 1. Zero. So these are the special ones. So we got the special ones. It's 30, 35, 60, radians is 5 and 6, 5 and 4, 3. Taking the starting value, which is kind of added centimeters and radians. Okay, so you're good with that, right? So now we're going to do this part of it. So it's that's the way. So just cover up the twos and it's all the same. So let's do so. Yeah. If you're ever dividing, when you're doing tangent or cotangent, just cover up the denominator and then just divide the numerators. Right? So you know the twos will just cancel out. Don't worry about the denominators.
Well, on the test, I will give you a blank one that you can fill out, and you'll use that blank one that you built on the test. But ultimately, I want you guys to be able to build everything from scratch. They're all quiz tests. Okay, number one. Rationalize that. One side top on by the So your answer's right, but we can just clean that up a little further. If I want to get rid of the radical in the denominator, I just multiply by root 2. Yeah, so make sure that after you get to your ratio, if your denominator has a radical, go ahead and rationalize it. Okay. Okay, this is good. You can reduce this a little bit. See that 2 and 2? Cancel it out. It's just these two. That's right, yeah. When dividing the negative or positive vice versa, I'll always. Yeah, negative. You got it. That's right. Yeah, you can reduce. That's what we want. Okay, yeah, so basically, if you're dividing fractions, all these have denominators of 2. So I'll just cover up the denominator, just divide it.